This is your 10-minute review of the spinal cord, which is part of the central nervous system because it's integrating sensory signals coming in from the arms and legs and back and sending them out. So here's the vertebral column, and the spinal cord is found in the vertebral canal or vertebral foramen. Now, I could spend 20 minutes cutting that. I'm too lazy. The spinal cord is surrounded by dura mater. And I'm going to put this on for a second. This is the sacrum right here. This is the lumbar region. 5, 4, 3, 2. So the spinal cord is going to actually end right there when we finally take everything off. So the spinal cord is covered by dura mater. However, there's a space between the dura mater and the vertebral arch. That's called the epidural space. Now I'm going to remove the dura mater. This is the arachnoid mater. Cerebral spinal fluid goes through this. I was taught it goes through this and the spinal canal. I was reading on a website that starts with a W and ends in pedia that the spinal canal actually closes as you age. So here's the spinal cord. Now remember, L2 is right there. Oh, wow, look, the spinal cord actually ends. So we're going to zoom in. And it ends in this structure called the conus medullaris. And you have all these little nerve roots that are dangling down, and they allegedly look like the tail of a horse. That is called the cauda equina. So this is the cauda equina. So these nerves are leaving in the lumbar and the sacral region, coccyx region. They're coming all the way down and they're exiting. They're forming sacral nerves, they're forming the remainder of the spinal nerves. This is the lumbar plexus, by the way, that's the sacral plexus. So, let's look at the spinal cord. Notice, it's wide here in the lumbar region, narrow here in the thoracic region, wide here. I wonder why. Oh wait, these nerves, they're going down. They're going to the legs. So this has to be wider for cell bodies of motor neurons for the legs. If we come up to the cervical region, oh look, it's wider up here too. It's because it's wider for cell bodies of motor neurons for the arms. So that is the longitudinal section of the spinal cord right there. So here's a cross section of the spinal cord. And I know this is anterior and this is posterior for two reasons. One, there is no swelling right here on the anterior side. I have swelling on the posterior side. That swelling is the cell bodies of unipolar neurons. So I know this is the posterior root ganglia. Second, I have a fissure right here called the anterior median fissure. So that's a big giant fissure. It goes all the way to the white commissary. That is called the anterior median fissure. And if we actually look at the horns of the gray matter, the posterior horns are a lot bigger than the anterior horns. So the spinal cord, we have gray matter that is surrounded by white matter. So the gray matter center looks like a butterfly. And it has 2 or 3 horns, depending on its region. The lumbar and cervical regions tend not to have a well-defined or a lateral horn at all. The thoracic region actually does. So the thoracic region has less gray matter because it doesn't go to the limbs, but it has this lateral horn that actually goes to the sympathetic nervous system. So again, the lumbar and the cervical regions are going to be wider. They're going to have bigger anterior and posterior horns because of stuff going to and from the limbs. The thinner thoracic region is going to have this lateral horn going to the autonomic nervous system, and we'll talk about that in the autonomic nervous system lab. So, the gray matter is cell bodies, and these gray cell bodies are going to have axons coming out into rootlets that go into a root, and this is the anterior root because that's the front of the spinal cord. Over here, we have cell bodies of unipolar neurons. Remember, those are sensory neurons, so we have senses coming in from the back and from the front and from the arms. It's going in. Their cell bodies are right there, and they're going in to interneurons in the posterior horn. So the posterior horn is sensory interneurons, Anterior horn is motor neurons going to skeletal muscles. And the thoracic region will have a lateral horn, which we'll talk about in the autonomic nervous system lab. So that's the spinal cord. We have a butterfly. We have posterior horns, anterior horns. We have a lateral horn on the thoracic region. So that's not really a lateral horn, that is. We have this gray commiserate, which I forgot to tell you. Don't worry, you didn't miss it. That bridges the left and right. And there's a spinal canal in the center again. Allegedly, it closes according to that website that starts with a W. Anterior median fissure. And there's a sulcus on the back. That sulcus is smaller. So the spinal nerves are actually going to come out, and this is a spoiler for today's lesson. And remember, there's rootlets and roots, and on the lab, I don't want you to worry about that's a rootlet, that's a root. We're going to call the whole thing a root. We have these rootlets coming down, and they're going to go out and form these spinal nerves that are coming out, and they go out between the vertebral discs. So this is the intervertebral disc. Now, if this is L1 and this is L2, this spinal nerve would be called L1 because they get named for the spinal nerve below for the lumbar region and the thoracic region. Now, the cervical region is different. We'll learn about that in today's lecture. So that's our spoiler for today's lecture. The spinal roots form these nerves, and the nerves are actually going to form rami. So this would be the anterior rami. This is the posterior rami, spoiler, autonomic nervous system. So that is our spinal cord review. 6 minutes and 43 seconds. Thank you.